and today I am going to deliver the part 2 of lecture 1 related to wastewater engineering, and it deals with the design of the sewers. And I am again requesting the new viewers to subscribe my channel to get more ideas and concepts regarding civil engineering. So I am going to start this lecture number 1 part 2 related to design of sewers, and it is very important as far as MPSC and diploma and degree level students to compete the other examinations too. First of all, we are going to discuss the design of sewers, and the design of sewer is different from that conduits used for conveyance of the water in case of water supply. You must know that the water flows in the pipes under pressure in water supply system, whereas in sanitary sewers the sewage flows under gravitational force only. So this is the first major difference, that water flows under pressure and sewage flows under gravitational force. For most of the period the sewer is partly filled with the sewage, whereas in case of water supply the pipes are always remains full. Means sewage is not running full in the sewers, however water is running full in the conduits of water supply. And due to above reasons, all the sewers are designed and laid at such a slopes that they can collect the sewage of the town and carry it up to the point of disposal. Then we are going to discuss the part 2, that is estimate of sanitary sewage. How the sanitary sewage is estimated. It is estimated mainly depends upon the spent water of the community draining into the sewer system, means spent water, and some quantity of groundwater, and also some quantity or part of storm runoff from the area draining into it. So every sanitary sewage consisting of mainly 3 parts. First part is the spent water by the community, second part is the groundwater, and third part is the storm runoff. The sewage should be capable of receiving the maximum expected discharge at the end of design period. In early years, provision should not be made much in the excess of the actual discharge, because otherwise it will cause the deposition in the sewer lines. The estimate of the flow for sewer therefore requires a very careful consideration and should be based on the contributory population and the per capita flow of the sewage, both the factors being guided by the design period. So that design period of the sewers is also important. The sewer should be designed large enough to carry the maximum discharge while flowing 2/3 full. For large sewers, for example, the diameter is more than 750 mm or 75 cm. So let us discuss about the estimate of sanitary sewage. How the estimate of the sanitary sewage is done, or the above margin is kept as a factor of safety against the following. So infiltration of underground water. The second is unforeseen increase in the population or water consumption due to festivals or melas, etc., and due to rapid development of the big industries and the town, or low estimation of the maximum flow. So the margin is kept for that while estimating the sanitary sewage. The design period. Sewers are usually designed for the maximum expected discharge to meet the requirement of the ultimate development of the area, because it is both difficult and uneconomical to augment the capacity of the sewerage system at later date. So perfect estimation is important. That's why the population estimate is guided by the anticipated ultimate growth rates, which may differ in the different zones of the same town. So in the same town there are different zones, and for the different zones the population is different and the use of water pattern is different. So it is very important to estimate the design period considering above points. The sewer lines are designed for a design period of 30 years. That is important, and this question appears in the objective type of examinations, that how much design period is required for the sewer lines, and that is generally it is 30 years. Population estimate. The most suitable approach for the design of sewers is to base the estimate on the anticipated ultimate density of population, or FSI, that is floor space index, and when the desired information on the population is not available in the master plan of that town, the following densities may be used. Up to 5,000 population, the density of population per hectare is 75 to 100 hectares. 75 to 100 population per hectare. Then for 5,000 to 20,000, the density of population per hectare is 150 to 250, and for 20,000 to 50,000 it is 250 to 300, and for 50,000 to 1 lakh it is 300 to 350, and above 1 lakh the density of population per hectare is 350 to 1000. Then we are going to discuss the area and per capita sewage flow. Area. The tributary area for any sewer section under consideration should be marked on the key plan. That is very important. We mark such a tributary area on determining the catchment area of any CD work. In such a fashion, we have to mark such an area or tributary area on the key plan. The topography of the area, layouts of the building, legal limitations, etc., to determine the tributary area draining to the sewer section. The area for designing the sewer is to be measured from the plan. That is very important. So key plans and topography plans are very important to determine the area. Then per capita sewage flow. It has been observed that a small portion of spent water is lost in evaporation, seepage in ground, leakage, etc. But for the design of sewers, the entire spent water or water supplied per capita may be taken into account, and that is the sewer line should be designed for 150 liter per capita per day. Usually 80% of the water supply may be expected to reach the sewers. In some cases it is 90%, but in some arid areas it may be low as 40%. Such a questions are asked in the objective type of examinations. In the industrial area, some industries often use the water other than the municipal supply from their own tube wells and other sources, and more often discharge their industrial waste into corporation sewers. At all such a places, proper calculation of extra sewage entering into the sewers should be made separately. When the industrial waste is large, it should be segregated and treated suitably before discharging it into the sewers. That is very important. Then we are going to discuss the groundwater infiltration. The quantity of groundwater entering into the sewers depend upon the workmanship in laying the sewers and the height of groundwater table. Both are the important. As the sewers are designed for the peak discharges, allowance for the groundwater infiltration for the worst condition should be made as follows. For catchment area of sewer line, quantity of infiltration water is 5,000 to 50,000 liter per day per hectare. Length of sewer line 500 to 5,000 liters per day per kilometer of sewer per centimeter diameter. That is very important. And for manholes, that is 250 to 500 liter per day per manhole. These are the thumb rules for calculation of quantity of infiltered water entered into the sewer. Then we are going to discuss the estimate of storm runoff. That is the third part of sewage. The empirical formula that are available for estimation of the storm water runoff can be used only when comparable conditions to those for which the equations are derived initially can be assured. A rational approach therefore demands a study of existing precipitation data of the area concerned to permit a suitable forecast. However, the storm waters are not designed for peak flow of rare occurrence such as once in 100 years. It is necessary to provide the sufficient capacity to avoid too frequent flooding in the drainage area. Then flow assumptions, that is very important. The flow in the sewers varies considerably from hour to hour and season to season, but for the purpose of hydraulic design of the sewers, it is estimated peak flow which is adopted. The peak factor or the ratio of maximum to average flow depends upon the contributory population, and the following values are recommended for design. For contributory population up to 20,000, the peak factor is 3.5. For population 20,000 to 50,000, it is 2.5. For 50,000 to 7,50,000, it is 2.25, and above 7,50,000, it is 2. So these peak factors one must remember for designing the sewers. Velocity of flow. Sewage of all towns carries the large amount of organic and inorganic solid matters, which remains floating or suspended due to flow of the sewage. If the velocity of flow is small, the floating and suspended solids will get deposited on the bottom of the sewer and will go on accumulating, thereby reducing the sectional area of the sewer and will cause the obstruction to the flow of sewage. Therefore, while designing the sewer, the velocity in them should be kept such as no solid gets deposited in the sewer. The minimum velocity at which no solids get deposited in the invert of the sewer, invert means bottom of the sewer, is called as a self-cleansing velocity. Diameter of the sewer is 15 to 25 centimeter or 150 mm to 250 mm. The self-cleaning velocity is 1 meter per second. For 30 to 60 centimeter, the self-cleaning velocity is 0.75 meter per second, and above 60 centimeter, the self-cleaning velocity is 0.60 meter per second. One must remember all these values for objective type of examination. Then we are going to discuss the minimum sewer size and sewer grades. Grades means slope at which the sewer is laid, and minimum sewer size means the dimensions of that sewer. The minimum size of public sewer should not be less than 150 mm. However, recommended practice is to provide 200 mm size. In hilly areas where the maximum slopes are available, it may be reduced to 100 mm. Sewer grades. The sewage flows in the sewer under gravitational force only, which is obtained by laying the sewers on the slope or a grade. The velocity of the flow directly depends on the grade of the sewer by hydraulic mean depth and the condition of the sewer with respect to roughness. The designer has to determine the optimum slope or grade at which the sewers are to be laid, so that self-cleaning velocity is developed in the sewage flow. So for grade, self-cleaning velocity is also important. Then we are going to discuss the limiting velocities. The lowest velocity in the sewer line should be equal to self-cleaning velocity as discussed earlier, so that up to certain limit the suspended and floating solids should flow with the sewage. The velocity in the sewer cannot be increased up to any limit, because if the velocity is increased, too much solids carried in the suspension will move in contact of the sewer material, and they will cause wear and tear to the contact surface and will also make the sewer surface rough. At higher velocity, the flow of sewage also becomes turbulent from streamline flow, and this will cause reduction in carrying capacity of sewers, as well as it will reduce the life of sewer. That is very important, and such a problem of high velocity occurs in the hilly areas where the sewers are to be laid at the steep natural slopes of the region. The high velocities in the sewers can be controlled by limiting the grades and providing drop manholes. So one must remember, to reduce the steep grade, one must provide the drop manholes at suitable place, in the same way as falls are provided in the irrigation canals to control the velocity of canal or a channel. Then we are going to discuss the method of design of sewer that are important. First step is zone formation. as discussed earlier. The whole town or city in which sewerage system is to be provided is divided into the different zones. The layout of the sewers is plotted along the roads and each zone is marked separately. The sewer which will carry the sewage and the storm water of the particular zone is also marked. Then sewer network. The proposed arrangement of network of sewers for different zones is then worked out and marked on the plan. The low-lying areas are marked separately and are isolated from the main sewerage system because pumping is to be done in that case and the pumps are to be installed at suitable places. As the sewage flows under gravitational force only, the sewage starts from the high level zones to the low level zones and finally flows to the point of disposal. That is very important for gravitational flowing. And sewage quantity, the quantity of sewage maximum as well as minimum to be carried out by each sewer is worked out and the variation factors are also determined and the actual quantity of sewage for which the sewer is to be designed is to be determined. Then we are going to discuss the method of design of sewer, the fourth point, that is flow velocity. The suitable velocity of flow between self-cleaning velocity and limiting velocity is chosen for the design purpose. The value can also be determined by the empirical formulae. Sewer section. Now the sectional area of sewer is A, that is Q divided by V. We note the major formula, that is Q is equal to AV, that is discharge is equal to area into velocity, is determined by relation. That relation and from the area of the section of the sewer is to be determined. Then grade of sewer. Now the slope of the sewer line is determined and longitudinal section of the each sewer line is drawn to a suitable scale. These sections show invert levels and all sewer appearances. Now keeping suitable depth of the sewer from the ground level at the highest point or a point of disposal, laying of the sewers can be started. So this is enough for this lecture. So you must study this lecture. This lecture is very important, and for more details and notes you may contact me on my email ID, that is svkulkarni72@gmail.com. So thanking you for watching my lecture carefully till end, and I am again requesting you to subscribe my channel for getting ideas cleared in civil engineering. So thank you very much.